The title dramatically says there's absolutely nothing new here. That's not exactly true, but I'm really just taking stuff you know from all other places and combining it into one. So we'll just simply combine things we've already seen before. No new derivative information here, basically. Find the derivative of each function and simplify it. Well, the problem with this one is it's got brackets inside of brackets, so I want to show you a little trick to handle that. This is not ready to take the derivative, so I'm going to do this. But notice I've gone to square brackets. Square brackets really helps me to organize my thinking when I got some chain rule stuff involved. Because if I didn't have the square brackets there, it would be easy to get confused between what bracket I'm talking about. So really nice to have square brackets here. So this starts off, and you really have to get good at focusing your attention on a bracket squared. See, put my hand over that. I've got something to the 1/2. That's that u to the 1/2. Just something inside here to the 1/2. And don't spend a lot of time staring at what's inside, or you'll get yourself distracted by a little mesh you got going on in there. And so if I do that, if I just keep myself focused, and the square brackets help that, as I go, okay, I need bring the 1/2 down, keep whatever's in the brackets, and I'm copying it down, but I'm not really thinking about it too much. I'm just copying exactly what's there, and I'm reducing the exponent by 1. Then allow yourself to look inside after that. You go, okay, derivative of the outside evaluated at the inside, or dy by du. Take the derivative of y, but just keep this inside just the way it is. Then multiply that by the derivative of the inside. Derivative of 1 is 0. I'm going to write the 0 even though most of you probably won't, but just so that you can, it helps to organize the thinking here, to write the 0 and say, okay, I'm now at the inside. Plus, and I'm going to write all these 1s in here that you don't really need. See, I go 2 times x minus 3 to the 1. You don't really need that 1 there. And then times the derivative of the inside, but the derivative of the inside is just 1. So I didn't forget about the chain rule. It just happens to be a 1 this time. And then I'll show what is the last step, really, which might be the toughest step, but it has nothing to do with derivatives. It has everything to do with algebra. So let me know if it's trouble. Here's the numerator. Here's the denominator. Oh, it's not the last step. There's another step after this, but I'll get this down first. And then give you a minute to process that. And then you can tell me if you see what the last little mini step is while I check this. 2 bracket, yep. It all looks good to me. What's the last step? Even if you don't understand that step, what's the last step, Simon? Cancel the 2's. This is what the common factoring was all about, is that with common factors, then if there's cancellation to be had, you'll be able to get it. Whoops. I don't know why I wrote f double prime there. I get x minus 3 over 2 root 1 plus x minus 3 squared. Okay, but do you want to talk about that second last step? Let me go through it. This was all positive power, so it stayed up in the numerator. The 0 was gone, the 1s are all gone, 2 bracket x minus 3. This square bracket over here had a negative 1/2, so negative says bring it to the bottom, and 1/2 says go to a square root. 1 over 2 is still there. 1 times the top, which I don't need that 1 anymore, and the 2 is in the bottom. So lots going on there, but what questions do you have? Go. Oh, yeah, absolutely. I canceled it and then just recopied it. So wound up about my next explanation. I forgot to actually cancel it out, which is a good reason to actually do this. Yeah, it's a good reason to just write it like that so you don't make a mistake like I did and forget to actually get rid of it. Good. Questions there? More time? Well, we're 1 for 6 already. Number 2. Okay. This one is a lot like the one we did in the last lesson, except it's a product rule instead of a quotient rule. So we can warm up and get back up to speed about that crazy quotient rule one I did earlier and just practice with the product rule one. So here, there's the first. I'm going to do it a little faster since we've already done one like this before. Derivative of the first. And I'm going to underline that whole thing so you can really see the first and the second in all this. There's derivative of the first times the second plus derivative of the second times the first. And I'm going to do that thing again where I underline the first function so you can really see the difference between the two. So I get derivative of the first using chain rule times the second plus derivative of the second using chain rule times the first. Now comes that one I call the half step, and that's my own invention of calling it the half step because it helps people remember to do it because it's got its own little weird name, half step, where you just tidy up the monomials a little bit. It's going to help you choose your common factor well if you tidy up monomials in the next step. So really not much going on here. 4 and a 2x in the first bracket, so that becomes 8x, or in the first term. A 3 and a 4 in the second term, so I get a 12. And then common factoring. You see, as it sits there, following my 98% rule, you'd have to take each of those brackets and expand them all out. And what a nightmare that would be with cube and power of 4s all laying around out there. But the common factoring will damage this big. It'll knock the powers down for us. So I look at the monomials first. 8x and 12. I can pull out a 4. There, at least there's a 4 I don't have to multiply out in all these things. Then I look at the x squared plus 3 to the power of 3, and I'm going to put that in yellow highlight so you can really see that thing. And it's got an x squared plus 3 to the power of 4. And this surprises people sometimes that it works out so nicely like this, but it's the nature of the quotient rule. The quotient rule uses the first in both sides. It has the derivative of the first over here, and it has the first function over there. So it's going to be in both. The only difference is the exponents will have changed by exactly 1. Every time exactly 1, because that's what the derivative does. It reduces exponents by 1. So I've got x squared plus 3 cubed, and I've got x squared plus 3 to the power of 4. And I'm warming up for an example that's coming. How many can I take out? 3, the lower number. Yeah, doesn't seem like a big deal here. You might have already known it was going to be the 3, not the 4. But I really want to define why we do that, because we always take the lowest number out. So I get x squared plus 3 cubed. There's also going to be a 4x minus 5. I've got 2 and 3. I'm going to take the lower. And watch the magic in the square brackets. Things are going to be much improved. Focus on that first term. What's left of the monomial? It was 8x. I took out 4, so now I got a 2x. X squared plus 3 cubed. Gone. Factored. Gone. No expansion. Nothing. It's finished. And then 4x minus 5, I've only got 1 left. Take a look at that. Literally, I could leave that part on the board. The grade 9s are literally doing those right now. Yeah, so the brackets just got a whole lot easier. No crazy expansions. Other term. I took out a 4, so I've got a 3 left. 4x minus 5 squared, I took the whole thing, but I didn't take all the x squared plus 3s. There's one x squared plus 3 left. And you may react like that, go, well, isn't that nice? Didn't that work out good for you? That all that was left was 1 of each thing. Of course there was only 1 of each left. I changed the exponent by 1 when I did the derivative. The difference in the exponents will always be 1. And then I'll do the last 2 steps because I don't think that they're too heavy at all. And then I'll pause for questions. And technically what's left in that bracket might factor, but you'll find generally speaking it doesn't. After everything that's gone on here with product rule and chain rule and everything like that, it would be quite shocking if what was left actually did factor. In this case, if I needed to get that 0, I could use the quadratic formula. If it was a larger exponent than that, then I've got a problem on my hands. And we'll talk more about that problem a little later. For now, they make them pretty simple. When you actually have to find them, is usually this comes down to like an x minus 1 or something like that, and finding the zeros is not too bad. Maybe you're finding that there's two kinds of homework questions. One where it's like, find this ridiculous derivative. But when they want to actually sub things into it and find the zeros, they usually give you a reasonable derivative to actually use to solve problems. Not many times they use something crazy like this yet, where you have to find its zeros or anything like that. Questions? You can hear the tone of my voice and making it like it's so easy or something like that. No, it's one of the craziest algebraic problems you've seen yet. So I'm not trying to dismiss it and make it like it's so easy or something like that. But I do need you to give me some direction on what to explain more. Is it good? Some tentative nods. Maybe the tentative nods, I hope what those mean is like, yeah, I pretty much got it. I got to practice it. I got to walk through it myself, but I get what you're aiming at there. More time there? Yeah. Quotient rule with chain rules inside and a troublesome exponent. This one's got it all. You can land this thing, you can land anything. So let me slow down here. I'm going to get this thing ready. Third root is not written the way we like for derivatives. We want the exponents as fractions or as negative exponents. When we're taking derivatives, in the final answer, we want it the other way, which right now just seems like me making up rules. In a few lessons, it'll be clear why we want the root back in the final answer. Well, it starts off not as bad as you might think. And then it heats up from there. Derivative of the top times the bottom minus derivative of the bottom. Oh boy, here we go. Derivative of the bottom. This is where I'll hesitate. After I write this down, I'll let you stare at it for a minute. Derivative of the bottom times the top all over the bottom squared. And if you claim you have no questions, I'll be stunned. I think there's 2 looming questions after I write that line. While you come up with your 2 questions, I'll just make sure I wrote it down right. To the top times the bottom, yes. Minus to the bottom times the top, all over the bottom squared. Yeah, it's good. Madison, what's the question? How did I do the derivative of the bottom? Yeah, okay, good. Good first question. I just stared at this and I said, okay, chain rule. Means bring the 1/3 out front. Reduce the power by 1. So 1/3 minus 1 is negative 2/3. Then multiply by the derivative of the inside. That's the chain rule part, which is that 2x. There's another 2x that came later. And it looks weird that I wrote 2x twice. It looks like an error. But this is from the inside, and this is where I'm going to get out blue and go, okay, this is the derivative of the first times the second, and this is minus derivative of the second times the first. See, there are 2 different 2x's. One from the derivative of the inside, one from the numerator. Other questions? I really thought you were going to ask me about the denominator. X squared plus 4 to the 1/3. If I square all that, basically I'm multiplying the 2 exponents, so 1/3 times the 2 gives me the 2/3. No other questions? Amazing. Same steps here. These fractions are scary. I get it. But same steps. Tidy up any monomials you see. Monomial, oh yeah, there's two monomials there. There's 2 in this one. And this one has negative 4x squared over 3. Did I have that right? Negative 4x squared over 3 all over the denominator. And after doing that half step, which is just tidying up monomials, all I did was tidy up all the one-offs there, then it's common factor time. Now, this is tough to explain. I'm going to choose as my monomial common factor, I'm going to choose a 2. But I'm also going to choose to take this denominator with me. I'm going to common factor out the denominator. I don't want what's left over in the square bracket to have a whole lot of fractions in it. I'd rather have the fraction out front. It causes some thinking problems, okay? So wait till you see it all play out before you decide that I'm nuts. I'm going to factor out this 3 out of the denominator. Then I got a decision to make. And I hope I set it up just right because I keep repeating it again and again. I've got x squared plus 4 in both terms, which I'd like to common factor out. What should I take out? Should I take out 1/3 or negative 2/3? How did we make this decision before? Went lower. It's this one that you take out. And in a second, you're going to see why. If you're wondering why did you take out that 3, and if you're wondering why do we have to take out the lower one, just wait till what comes out of the brackets, and you'll see why I've done it this way. So that's x squared plus 4 to the negative 2/3. Now, taking the 2/3 out of 2, it doesn't seem like I should be allowed to do that, taking 2/3 out of 2. So I'm going to think of it backwards to think about what has to go here that I can multiply by 2/3 and end up with the 2. I mean, whatever's here has to, if this distributes, the 2/3 times it, has to come back out to 2. What number do you multiply 2/3 by to end up back at 2? 3. That's why I chose to take the, that's why that's why I chose to take out 2/3. Because now there's no fractions in the bracket. Yeah? Now look at this. This is really hard. Really, really hard. X squared plus 4 to the negative 2/3. X squared plus 4 to the 1/3. What do I have to write here that if I multiplied it out, I'd end up back with 1/3. So it's going to be x squared plus 4. But the exponent on here is going to be such that when I add negative 2/3, I'm going to end up with positive 1/3. Really difficult. But wait till you see what the number is. The number is going to boggle your mind. And then I'm going to explain it, and you're going to go, oh, of course it is. What's the number? 1. Like, how can it be 1? Really, after all this, it's 1? Come on. And I say, how could it not be 1? We reduced the exponents by 1. They have to be different by 1, because that's what we did. That's what the derivative did. It's so nice. And so I wrote the 1 there for you for the first time you go through it, but we didn't need that 1 there. Yeah? Now take a look at the other set of brackets. It was a fraction, but since I took the 2/3 out, it's not a fraction anymore. And so my square brackets are nicely no fractions. You don't have to do that, pull the fraction out like I did there, but it certainly makes it nice. And then what about this? I factored out x squared plus 4 to the negative 2/3. Oh, I factored the whole thing out. Look at that square bracket. Everything I did there, if confusing, you should at least be motivated to go, well, I'm not sure everything he said there or why he did it, but the result was awesome. Look at that incredible square brackets. It's back to something the grade 9s would handle. No trouble at all. Just going to resize this whole thing. And I'm going to do the next step just because I really love this step. I really love everything that happens next. I'm going to write it down, and you might have questions, but it might go the other way. You might look at it and go, oh, and you might see everything that happens here. Okay, so g prime at x equals 2 bracket 3x squared plus 12 minus 2x squared. Here's the numerator. The denominator is 3 x squared plus 4 to the 2/3, x squared plus 4 to the 2/3. You process that, and I'll get the last step done here. No, last two steps. 2 bracket x squared plus 12 over, oops, I'm going to have to move that guy down there for a little while. And the bottom is 3 bracket x squared plus 4 to the 4/3. And my final answer, 2 bracket x squared plus 12 over 3 cube root x squared plus 4 all to the power of 4. Let me just check those last steps to make sure I didn't make any mistakes there. Yep, 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 yep. But I mean, you got to have questions there. Or maybe not. Maybe if you stare at it long enough, you're like, oh, I see what you did there. Question, Madison. Oh, yeah, yeah. Yeah, not taking that common factor, that whole number common factor, it doesn't hurt you per se, like not taking this 2 out. It just makes the numbers bigger in here, and you'll common factor at the end. So, yeah, that's no problem. Madison did it, and she didn't take the same common factor as me, but she ended up getting the same right answer because she common factored it later. So the common factor sometimes doesn't hurt you that bad by not taking it with you. Certainly when the common factor is like a 2, you'll be able to survive even though that common factor stays alive inside the square bracket for a while. What questions do you have? All right, I'll ask you a question. Where'd this go? Yeah, it dropped to the bottom. And you go, well, what a surprise. It's the same thing. How does it always work out to the same thing? Well, because that's where this thing came from. It came from derivative of the bottom. You know what I mean? So it's not surprising that these things appear and reappear. Emmett. Yeah, it doesn't have to be. You got your choice there. That's an old habit of mine. Generally speaking, when I used to do these, the one time I ever taught 11U, is I really tried to say to students, I think that cube root, you really want that to go first, because it's going to make the number smaller, and then you can make it bigger afterwards. The 4 makes it bigger, and then you got to make it smaller, and then the numbers get out of hand. So when we were actually trying to do them in class, we sort of, it wasn't a rule, but we just said, generally speaking, having the cube root go first is nicer. But it doesn't actually matter. You can have this with a 4 in there and then cube root it after, and it's the same thing. Great question. I don't even know what year that was. What year did I teach 11U? My 3rd year? 2003? Is that what year you guys were born? Oh. It's Mr. Todd's old day, Selena. Every story ends up with, man, I'm old. She's like, yeah, wow. You have questions here? Just as a side note, I just need to tell you, I've been teaching these examples for, a long time. 20 years of these examples. And what I want to tell you about that is, when you feel overwhelmed by all this and you look at it and go, this is impossible. No, it's not impossible. 20 years of kids, 50 years of kids have gone through this. Plenty of kids less smart than you have found their way through this. It's not impossible. Yeah, and this is the game. And it can be done. Is it easy? No. If it was easy, everybody would do it. 4. 4 looks hard, but it can be handled in a slightly different way, in such a way that it doesn't end up being that bad. See, this exponent of 10, if I put that exponent of 10 on both the numerator and the denominator before I start, which you could do, you end up with a pretty big mess. But you could do this. It's hard to see a little bit, but it handles it nicely. You could go, okay, g prime equals, bring down the 10 and reduce the power by 1. I've got more work to do there, but that handles the big exponents right off the hop, which might make you think, well, why didn't you do that before? It only works if both these exponents are the same. If I put a 2 in the numerator and a 7 in the denominator, you can't do this. But when the exponents are the same, maybe having it out there and dealing with the exponent just like that as a chain rule, maybe that's a pretty good way to handle it. On the very next question, I'm going to do it the other way. So if you're worried I'm leaving a method out, I'm not going to. On the next question, I'll go, well, let's try it the other way instead. And you could do this question the other way. So that's the derivative of the outside. Bring down the 10 and reduce it by 1. Then you need derivative of the inside. So that's derivative of the top times the bottom, minus derivative of the bottom times the top, all over the bottom squared. And I did that fast on purpose, and I'm willing to answer questions, but I just wanted to establish that I've made that inside derivative a lot easier by dealing with the 10 on the outside. Did I do it right? Derivative of the top times the bottom, minus derivative of the bottom times top, all over the bottom squared. And you see, no crazy exponents in there. A pretty nice little expansion I have to do here inside. Nothing too much work. Let's see. 2x minus 2x cubed plus 2x plus 2x cubed over 1 minus x squared squared. And I'm going to do something that looks senseless at first. Yeah. What did I do in that last line? I mean, even if the other lines you have questions on, that's fine. You can go back to those questions in a second. But what did I do from here to here? Not just that, but why did I do it? Because I'm not done yet. Why did I take that 9 and put it on both sets of brackets? After starting the question by going, let's not do that. Maria? Yeah, the results, the result came out with these two things here, right? And so I think that's a little better. This time, up there I decided, no, don't do it. But when I got down here, I said, no, let's break these things out, because then I can combine them with the other parts. And on the top, I get 40x, 1 plus x squared to the 9th. And the bottom, I got 1 minus x squared to the 11th. So if you're looking for an interesting exercise, some extra work, you take this and put the exponent 10 on both at the start, and then try the derivative that way and see if you can land it. Whose appointments? People leaving at 1:30, right? Is anybody leaving before 1:30? No, because I only got 2 more to go. I should be able to hit 1 o'clock, but it might slip past 1 o'clock. Questions there? What questions do you have? More time? Who needs more time? Lots of people need more time. I know, if you're out there going, really? Are you kidding me? It's getting crazy. I'm like, oh, we're just getting warmed up. Like, we're here till April, folks. Like, so just get in it. Yeah? Let's go. You didn't come all this way to only come this far. Although I have noticed, I need to tell you, I have noticed, there's a handful of people that seemed, when I taught you those few weeks in advanced functions and through the first few weeks of this course, seemed unenthused by all this, and now seem a little more enthused. It's starting to get more algebraic in nature, and for some people that's like, oh, now this is starting to be more what I like, you know? Advanced function can get a little wordy sometimes, where this is like, math, math, math. Just do the math, yeah? More time? Yeah, here we go. This time with the squared out there, I could do it with the chain rule like I did last time, but instead I'm going to distribute the squared on it and try it that way instead, because you can do it both ways. So f at x, no, it's a t. F at t, 5 plus 3t to the 2/3, 1 minus t squared, all squared. I'm already writing too big. I'm never going to fit this in if I'm going to be writing that big. Just scale that down a little bit. Well, don't let me lose you already. Tell me if you don't see what I did there to get ready for this derivative. I took the root 3 and I turned it into 1/3, but that was squared, so I made it 2/3. And the denominator, I just made it squared. So this time I did it differently. I went ahead and squared both things before I started the whole thing and handled it that way. One's not better than the other. Each has its own advantages and disadvantages, but in this particular one I chose to go ahead and distribute those things. So here I go. Quotient rule with a chain rule inside. Derivative of the top times the bottom. And I'll underline that top just so you can see that whole derivative of the top. Minus derivative of the bottom. Times the top. All over the bottom squared. And there's lots of little details there, and I encourage you not to get too freaked out by the details, because those details will come as you practice them. What I really want to talk about is the steps that happen next. Let me just read it over again to make sure I haven't made a mistake, and then I really want to talk about how you deal with this giant mess that's just happened here, because I think I've given you all the weapons. We just need to sort the weapons out. 2/3, 5 plus 3t negative 1/3 times 3, 1 minus t squared squared, 2 minus 2, negative 2t, 5 plus 2t. Yeah, okay. Looks right to me. What's next? What do I do next? Slow down, what? Okay, yeah, you're still copying. Giving you lots of time to think of what's next. I've tried to describe this next move. There's 2 right answers here. What's one of the right answers? Yeah, get the monomials. Just tidy things up a little bit to get ready for common factoring. Common factor is really the big next step, but this tidying up the monomials move really makes that common factoring a little easier to see. I'm going to get sidetracked for a second and tell you about my second semester linear algebra prof. He looked out at us one Wednesday morning at 8:30 in the morning. I remember it plain as day. It was late in January, so the enthusiasm of Christmas had already worn off. And so we were sitting out in our this giant lecture hall in our little chair with the fold-out desk. Do you know what I'm talking about? The little university fold-out. You got a little desk about like this that you could scribble your notes on. And he looked out and he stopped in the middle of an example, which none of us were understanding. We had no idea what was going on. Total dead silence in the lecture hall. And he stopped and says, "You're not getting any of this, are you?" And we're like, "Wait a minute, no, nothing." He says, "Okay." He says, "Best advice I'm going to give you. You're year one people. I totally get it. There are times when all you can do is just get it all down. In this case, you guys have the videos afterwards. Things have improved. Get it all down. I'm not telling you to give up on this lesson because it's not quite as bad as it looks. The incredible amount of algebra makes it look like there's dramatic things going on here, and there's just really not. It's just some algebra." He said, "Get it all down." He says, "And then leave here, have your lunch, open it back up, go over it line by line, and work it out." The next thing I want to tell you about is we went to tour the University of Waterloo, and the person that was doing that, this is after she'd been accepted and she was going to be going, and it was like an introductory thing for parents and for students, but it was more to tell the parents to get out of here. Basically that was trying to tell us, leave them alone now, let us do this. And they said that the model of teaching high school is like this. The teacher teaches you 80% of what you need to know, and 20% of it you're supposed to pick up from doing the homework, reading the textbook, and figuring it out yourself. Sort of an 80-20 model, which I thought, that's pretty good, actually. My experience has been that students get pretty upset if I don't hit about 95.5. You know what I mean? Like, they get pretty stressed to go, "Well, you didn't show me that in the example." I'm like, "Well, I know. I've only got, I got this much time." And they said the university model is 20-80. Prof will come in and say, "I'll show you about 20% of what you need to know. Give you the basics. You go out there, use your textbook and your friends to figure out the other 80%. You believe those numbers? And it's worse than that. It happens all in 1 year. It happens from June to September. It's like, okay, now you're supposed to be able to figure out 80% on your own. So that modified the way I teach a little bit. I used to be very, what's the word? Nurturing's not the word. I used to be very right with you every step of the way, and then I realized maybe you're not helping them out enough by leaving them with stuff like this a little bit, pounding through it, and I've done it with the grade 9s too, and say, I'm going to pound through this, and you get it worked out. It's where you're headed. In the middle of COVID and everything like that, it's scary stuff. I get it. You're just going to have to trust me. I'll tell you when things are getting difficult. I'll tell you. And you're like, it always seems difficult to me. I'm like, no, there are some things, and I use the quadratic formula as a perfect example of that the day of the quadratic formula lesson, the grade 10s look at you like you are nuts. Like you are just, they just throw their hands up and go, that's it, I'm done. I'm telling my mom I'm not doing math anymore. Right? And then you go home and you try one. And you try another one. And a few minutes later, you're like, oh, this quadratic formula is easy. Because it is, because there's a set of steps. Do this, then do this, then do this, then go home. Yeah? You find out later with some math stuff, it's like, there's no formula here. There's no order of steps. You just got to be able to figure this out. You'll get this. Yeah? I can see the look on some of your eyes. You're going to get this. This won't be the hardest thing we face this year. You work your way through it. And especially questions like this. Will you get the answers perfect all the time? No, but a question like this, everybody on the test gets 3, 3.5, or 4 out of 4. You can mostly do it. But one little thing happens, I dropped a negative there and it didn't work out. So lower your stress level. No, I'm going to get to this over the Thanksgiving weekend and try these out. And maybe you haven't even done any of the chain rule homework yet. Well, what chance do you have of really following the intricate details of this? So focus on the big steps. Here's the big step. Erica nailed one. She said, collect up those monomials. Did I do it? Yes, I did. Collect up those monomials before you go after your common factor, okay? And I've already given away the next step, but just to really reiterate those big steps, let me say that out loud again. After doing the collecting up the monomial step, what's the next big move? Yeah, factory. Look for those common factors. It's going to tidy things up a lot, okay? So even if all the algebra is sort of going by a little bit, those are the big things you're going to need. That's the knowledge you need from me in all this, is what should I do to manage this? Look for those monomials, then look for the common factor. Look at the monomials first, 2 and 4t, pull out a 2. Look at the next set of brackets. 5 plus 3t to the negative 1/3. 5 plus 3t to the 2/3. Well, I know it's 5 plus 3t. Which of the two numbers do I take? The lower one, yeah, the negative 1/3. Then I got a 1 minus t squared. I got a 2 and a 1. I take the lower number, which is the 1. And then apparently great stuff's going to happen in the brackets. And it will. Great stuff's going to happen in the brackets. I factored out the 2, that's gone. 5 plus 3t to the negative 1/3, that's gone. And I took one of the 1 minus t squareds. All I have left is 1 minus t squared. Look how lovely that is inside the brackets. Next term, I took out the 2. I'm left with the 2t. I took 5 plus 3t. Oh, I took out the 1 minus t squared. I took out the whole thing. This one, though, this is the big moment. And it's really difficult, except it's so shockingly easy that it boggles the mind. You go, I've taken negative 1/3 out of 2/3. You're like, what in the world is going on there? It can be done, actually. 2/3 subtract negative 1/3 is like 2/3 plus 1/3. That's 1. Can it really be 1? Can anyone explain, not only could it be 1, why it has to be 1? There's no other choice for it to be. 1. Yes, one of those. And don't answer, it has to be 1 so that my life is easy. That's not the answer. There's a structural issue going on in this whole thing that makes it that it's going to be 1. You really don't have to think about it. Yeah, that's where it came from. 5 plus 3t, where did it come from? I subtracted 1. So these two exponents are going to be 1 difference. It's the only thing we ever did to exponents. The only ways the exponent changed was subtracting 1. So it's exactly 1 off. And look at this bracket. Done right, you look at the square bracket and say, well, I can live with that. And this whole page of crazy algebra, I can live with that. Did you just hear knocking, or am I having a stroke? Did I already resize this once? Twice. I'm going again yet, so I never really thought about it, but I guess it sort of works out because you're probably reasonably caught up with copying. And the last line I did is always a reasonable size. The upper stuff is getting pretty small, but yeah, that's right. Let me do the last step all at once, because last time I did that and everybody seemed okay with it. But if you're not, I really want to answer your questions. I got a 1 minus t squared cubed. You think over how it became a cubed. I've got a 3rd root of 5 plus 3t. You think that over and see where that all came from. I've got a 2, and then I'm going to try and do this whole bracket all at once in my head. It's a 10t. Oh, that's a 6t squared. So I think it comes out to 5t squared. I'll double check that in a second. Plus 10t plus 1. And I'll double check all that in just a second. Out of the brackets, a 10t, yes, and a 6t squared, but a minus t squared is 5t squared plus 1. Yeah, it's good. Okay, which parts do you want to talk about? Go. Anna. Oh, I'm just kidding. Maria. Yeah, it's a great question. He switches to blue. Who's got it? Who can see it? Look. I got lucky too. Look where they're written. Woo! Woo! That one canceled. Almost always something will cancel the denominator. We're pulling out this giant piece into other pieces. It's going to be out there when we need it. Eventually, at the end, something with the denominator cancels. And for some of you, you're starting to have that quadratic formula moment where you go, you know what, these are kind of repetitive, actually. Do the top times the bottom, do the bottom times top. Monomial, common factor, cancel. You know what I mean? There's sort of a set of steps here that starts to play out every single time. You don't practice them? Well, no, it's going to be a train wreck. Of course it's going to be a train wreck. You do practice them, they'll come along. What other questions? What else? Where's this coming from? Simon? Negative, brought it down. 1/3. I did it all in one step, made it third root. I'm not saying you necessarily will be there yet that you're going to do those all in one step, but I'm starting to, the reason I'm pushing is a little bit is you can see there's going to be shortcuts here. Once you get better at them, it's not going to take 46 lines every time. You're going to be like, boom, 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 boom. Got it. Fiona. Second and the third line. Here to here. Here to here. All I did was look for a common factor. I saw the 2 and the 4t, so I took a 2. I saw 5 plus 3t, and I took the lower exponent. And then I saw the 1 minus t squared, and I took the lower exponent. Okay with how I chose that? Then, looked at this term and said, what's left of that term? I factored out the 2. I factored out the 5 plus 3t to the negative 1/3. So all was left was one of the 1 minus t squareds. The second term, I took the 2 out of the 4t, leaving me 2t. The 1 minus t squareds were completely gone. And then this one, the difference between these two exponents was 1, so I was left with power 1. For those of you who were really into dividing to figure out what goes in the brackets when you're doing common factoring, you're taking this and dividing by this. So you're going 2/3, subtract negative 1/3, which is 3/3, which is 1. So you still can do that divide thing if you want. I find I do the multiply thing where I go, okay, I've got this. I got to know when I multiply this with this one, what does it take to get back to 2/3? And that's a 3/3, which is 1. Or once you get good enough of these quotient rules ones, you're going to be like, oh, it's 1. I subtracted 1 before. Unless I don't know how to subtract 1, the difference here is going to be 1, because that's where this number came from in the first place, was subtracting 1. Other questions? Before you completely freak out again, I want to tell you how far we've come in a week. It was just a week ago here where we were having a little trouble understanding vertical and horizontal asymptotes. That's what we were working on, comparing the exponents of the numerator and the denominator. So in a week, we've probably progressed more than you did in the previous 3 months of mathematics. You know what I mean? Like, it's heating up now because your algebraic skills are starting to pay off. So if you're getting a little overwhelmed by some of the details, don't start going, oh, I'm not good enough, I'm not smart enough. That's insane. You never would have got this far. You're plenty smart enough. It just takes a little practice, that's all. That's not true. That's the wrong word. It just takes a lot of practice, that's all. Look at this baby. Oh boy, here we go. Last one. And I'm going to use some curly brackets just to give you another weapon to manage all this stuff. To do the derivative of the top. This is a quotient rule with a product rule inside, with chain rules all the way through. Right? I'm doing derivative of the top only. I'm going to hesitate there until you're like, yes, got it, derivative of the top. Okay, to do derivative of the top, we do derivative of the first times the second plus derivative of the second times the first. Now I did that fast on purpose, and I'm going to check it in just a second. The reason I did it fast is because if you do your product rule homework, and then you do your chain rule homework, doing a derivative like that one, you'll be close to as fast as me. Exactly as fast as me? I don't know. I've sort of got 20 years experience on you. Some of you will get there. Let me just check. Derivative of the first times second plus derivative of the second times first. I think I nailed it. Well, now you're freaking out, right? That was only step one. That's derivative of the top. That was derivative of the top. In those curly brackets, that's derivative of the top. You see how many times I'm saying it over and over again? When you're doing these, you got to talk like that to yourself. Okay. To do all of that product rule was derivative of the top times the bottom Oh, so that's not so bad. That saved me. Can you imagine if the bottom was something complicated? It wasn't this time. Are we lost? Through the top times the bottom. Quotient rule. Through the top times the bottom. Minus. Through to the bottom. Okay, that was better. Through to the bottom was a little more under control, because root of x fourth is just 4x cubed. Times the top. Can I fit it in here? X squared plus 3 cubed times x cubed minus 1 squared. I did fit it in. All over the bottom squared. My goodness. Look at that mess. What was the next step in this, Erica? After I did the quotient rule? Collect the monomials. That's going to be true here too. Okay? So if the complete algebraic details are just flying by you, don't freak out about that just yet. Start to think about the steps that are involved here. We want to get the monomials organized. Now, in this particular case, I've got this big curly bracket with an x to the fourth out front. As I collect up the monomials, I'm going to be multiplying the x to the fourth into those and do that all in one step. And writing small enough to try and finish this whole line on one line here. So this first one has a 3 and a 2x, but also an x to the fourth times that whole bracket. So 6x and an x to the fourth, that's 6x to the power 5. And then I've got this x squared plus 3 squared, and this x cubed minus 1 squared. The second term in the curly brackets, all it has is a 2 and a 3x squared, but now that whole bracket's being multiplied by x to the fourth. So I got 6x squared and an x to the fourth. And then it's got these other things. And the last term, there's nothing really to do. Let's just see if I handled that right. First term has a 6x, but it's being multiplied by x to the fourth, so it's 6x fifth. And then the other two pieces. Then 6x squared, x to the fourth is 6x 6. Yes. And the last one, 4x cubed. Yes. Get it all down. Don't panic about the algebra. Let's worry about the step that was next. Common factor. Oh, sorry. I totally gave it away. The half-step monomial, and then we go right to common factor. And the common factors will be there, and things will tidy up nicely. Let's see, 6x fifth, 6x sixth, and 4x cubed. I think I can go with a 2x cubed. X squared plus 3 squared, x plus squared plus 3 cubed, and x squared plus 3 cubed. Oh, isn't that nice? I can pull out an x squared plus 3 squared. X cubed plus minus 1 squared, x cubed minus 1, x cubed minus 1 squared. I can pull out an x cubed minus 1. Go with my square bracket. Now I'm going to have 3 terms in the brackets. Oh, not a mistake. Oh, the computer hitched there. We don't have much time on this computer. After we see it hitch the first time there, it's not long before it resets itself. In the interest of saving some space, I'm going to, right over top of this, expand out this bracket, okay? Questions? Maria? Six x, and that whole bracket is multiplied by x to the 4. Good? Selena? This one here, I pulled out a 2. Oh yeah, I did that twice, didn't I? Selena's caught an error there. I changed it to blue so you can really see it there. 6x5, good catch, yeah. Happens all the time though. Drive you nuts when you're doing these things. Like, and you get all the way through and like, the answer is like 2x squared and you got like 3x squared and you're like, what happened? And you're mapping all the way through to find it. When you get down to those errors though, it means you're in pretty good shape. You get all the way down through one of these and it's 2 versus 3. We can live with that. It's when it's completely, you don't even know what the next step is. And that's why these steps are so important. The half step and then the common factoring step. I randomly switched colors here. Certainly. It is. It's the best of the best. Best day ever. And I'll resize. I'll resize. Once everybody catches up, I'll resize and do the last line. The last line's real easy compared to all this. Questions? Emmett? It's good? Yeah. And it happens every time. Every time eventually that common factor cancels out with the bottom. More questions? Is everyone down to the last line? If I resize, it's not going to mess you up too much because I want to get that last line down because I know there's a couple people that have to go. There'll be a version of this online. The whole video will be online because maybe you're totally like, I'm not ready for this at all. I can't even chain rule yet. No problem. That's why the videos, right? So you've gone through it once. You sort of get the feel for the steps, and then you can watch the video, you know, with your turkey dinner there and your stuffing, and you're like, let me just walk through this video again. Get you out of doing the dishes, though, eh? I'm sure you've used this trick, right? Dinner finishes. You get the feeling mom and dad are about to start cleaning up these dishes. Like, uh-oh. And suddenly it's like, it's okay if I just go work on my homework. They're really tough stuff in calculus. Just got to go get to my room now, get my books. Right? Bella used to do it all the time. All the time. The books came out as soon as she finished her dessert. You know, whoop, oh, got to study. She thinks she's getting me. I'm laughing. I'm like, I'll do my dish. I'll do the dish if you do your homework. It's a great trade for me. I love it. What's next? X cubes. What's next? X squareds. I did that fairly quick. I'm looking for people to check my collecting, my grade 9 collecting there. X to the 5th, 6, 4, yeah. X cubed, 9, 3, yeah. Negative 3, negative x squared, plus 6. What's the word, Selena? Did I get it? Selena's like, yeah. Oh, I thought I saw a hand. No? Questions do you have in those last few steps? I'm telling you, this one's not the one you got to worry about. You practice this, it'll be quadratic forming. You'll just like bang, bang, bang. This will be okay. The one you got to worry about that's caused no end of trouble in the past is that one, with the negative exponents and everything like that, and the fractions that pop out of it. That's the one that really floors people. You do a few of these, you're like, it's the same every time. It's literally the same every time, and they are. They're very repetitive. So give them a chance before you write them off. Simon. I got distracted. I did it here so that you can see I did a little... Yeah, I did it there so you could, it really highlighted this to show I did an expansion there just above it to save myself a whole step of writing there. But switching to blue at the end was just, I switched to blue there and then just kept right on going. This was the error. Selena busted me on there, so I changed that color, but that was just me being mad at myself, I guess. I wasn't mad at Selena, though. I was glad to get the correction. The guys who ordered Popeyes and didn't ask me if I wanted any, those guys, I don't know. Yeah. No half marks for them next time. Oh, yeah, great question. Check it out. Common factor of x cubed right there, x8 right there, so 3 of them cancel out, leaving x to the 5 in the bottom. I used to always cross them out as I went, and that's what you really should do. But when I'm copying it there, it sometimes messes people up because they're trying to copy it, and meanwhile I'm canceling it out. So I'm trying to balance between those two moves there. Other questions?